Hey fellow Earthians, I'm a bit late to the game with this video, I must admit, but chances are you may or may not have heard of a mysterious exoplanet that may or may not have extraterrestrial life called K2-18b. So a really interesting press release reported the strongest hints of biological activity outside of the solar system. And the author of this paper was quoted saying that a signal came through strong and clear, and that the best scenario for the data that they received is indicating a planet that's teeming with life. So you're probably someone that doesn't read science papers because, yes, frankly, they can be boring. But if you just base your knowledge off of this press release without reading the actual paper, you would probably think that we made this gigantic discovery of life on another planet. And I want to walk you through not only the press release, but the actual paper and explain to you why what they found is highly questionable. So there's a science paper published on the 17th of April this year, 2025, by Nikku Madhusudhan and his colleagues at Cambridge University. And the group reported that there was detection of biosignature molecules in the atmosphere of K2-18b. And biosignature means any substance, feature, phenomenon that provides evidence of past or present life. And the molecules specifically are dimethyl sulfide and dimethyl disulfide. And because I'll be referring to them quite often in this video, we can just call them DMS and DMDS for short. Anyway, the claim that they're making that they found these biosignature molecules only works if the exoplanet K2-18b is what we would call a Hycean world. And this is basically a world that has a thick hydrogen atmosphere and a water ocean. And because the team says that on Earth, DMS and DMDS are only produced by life, specifically phytoplankton that we see in our oceans. But actually, we first have to pause here because the fact that K2-18b is a Hycean world is actually controversial. Back in 2023, data from the James Webb Space Telescope, or JWST, found a lot of methane on K2-18b, not a lot of water. Actually, I don't think they found water. And now K2-18b has been called a lot of things, but saying it has a deep atmosphere with a water ocean is kind of trying to resurrect a hypothesis that we kind of already proved wrong. And also just saying that these molecules are only produced by life is kind of not true. And yes, on Earth, DMS and DMDS are mostly produced by phytoplankton, but these molecules have been found in other just very non-life sustaining places. For instance, these molecules were recently found on a dead comet called 67P. Okay, so now that we have determined that these molecules probably aren't even countable as biosignatures, there are a bit more problems with the actual analysis behind the data. And first, it must be said that the data itself is very noisy. So noise is referring to the background static obscuring what you're looking at. For example, the faint light of distant stars, planets, galaxies, etc. But think about it. You're trying to study a planet, the atmosphere of a planet that's so far away, and you can only see it when it passes in front of its star. So the signal itself is already ambiguous, and it's potentially explainable as a result of systematic noise or error even. So the detection the authors claim to have found of DMS and DMDS is a 3 sigma detection, and this is said in not only in the paper but in the press release. And a sigma detection in astronomy refers to the statistical significance of a measured signal. So what is the likelihood of it being a genuine astronomical phenomenon rather than noise? But actually, the claim of it being a 3 sigma detection is just not true. So the team, instead of applying like regular robust methods of analyzing a planet's atmosphere, if we look at this figure here, what they did was create a simpler model where they basically removed all of the molecules besides DMS and DMDS, as you can see, that have strong features beyond 0.9 microns. And basically, there could be other outcomes besides this specific one, but the model that they constructed artificially increases the significance of DMS and DMDS. So I want to quote Dr. Ryan McDonald, who is an expert in the atmospheres of planets orbiting other stars, and note that he actually completed his PhD at the University of Cambridge in 2019, where he actually worked with Madhusudhan himself. He said that the paper engages in statistical hacking to hit the magical 3 sigma detection. And I want to quote Ethan Siegel, who is an American theoretical astrophysicist and science writer, who says that the detection was actually only a 1 sigma significance, which means there's about 30% chance that the detection was a fluke. And in all subfield of physics and astronomy, a 1 sigma detection is known as a non-detection. So basically, there's no meaningful signal seen here. Okay. So the paper's primary claims, right, regarding finding life are just not as robust as we would like to think they are. Now we have to look at what happened with the science communication. So there are excerpts in the press release that just don't coincide with the paper itself. So for instance, if we look at the above quote from the paper, it says, while DMDS and DMS best explain the current observations, their combined detection significance is 3 sigma. We can kind of ignore the first part because it's not necessarily 100% robustly proved. But we can focus on the last bit of the sentence, which is, at the lower end of the robustness typically required for scientific evidence. So they're explicitly stating that 3 sigma, which first isn't really necessarily true, is at the lower end of what is needed for a detection, let alone saying something is a biosignature. But in the actual press release, they're quoted saying the signal came through strong and clear. And now I'm confused. That's confusing. If we look at another quote here, we can see the top is again from the paper. So the tentative inference of DMS in K2-18b opens up an important debate as to the possible presence of life on K2-18b. On the one hand, the low detection significance highlights the challenges in detecting such molecules. But if we look at the quote from the press release, given everything we know about this planet, a Hycean world with an ocean that's teeming with life is the best scenario that fits the data we have. I think I'm correct to say that those are different, very, very different things. Very, very different things. So I want to quote Dr. Chris Lintott, who you might have seen him from BBC The Sky at Night. He is a co-presenter, but he's also an astrophysicist and an author. This guy knows what he's talking about. And he basically says, and I quote, "Currently, it's not much more a hint of life, as the lottery ticket in my back pocket is a hint of my having £1 million by Monday." And actually, this is what happened when Dr. Lintott had a chat with Madhusudhan on BBC Radio 4.
It's a huge transformational moment, the strongest evidence yet for the existence of life elsewhere in the universe. That is the excited claim being made by scientists at Cambridge University after they detected tiny hints of gas molecules in the atmosphere of a planet that might just have been produced by life. We're joined by the man who is excited, Professor of Astrophysics and Exoplanetary Science at the University of Cambridge. He's Professor Nikku Madhusudhan, and we're also joined by the co-presenter of the BBC Sky at Night programme, Chris Lintott. Morning to you both.
Good morning.
Hello, good morning.
Professor, tell us why you're this excited.
Well, it's a transformational moment in astronomy and in science, because this is one of the longest standing questions in the history of science. Are we alone? And what we may be seeing are the first signs of being able to answer that question.
So why does the gas tell you that? Yes. Sorry, forgive me. There's gas around a planet. Just spell that out for us, if you would. What exactly have you seen?
It's called dimethyl sulfide or dimethyl disulfide. We are seeing potentially one of the two gases, both of which are known to be caused from life here on Earth.
And you carefully added the word might. I used the word hint at.
Yeah.
There's more work to be done.
Yeah, I mean, the observations that we're making, the detections we're making are at what is known as a 3 sigma level. So there is still a 0.3% chance that it might be a statistical fluke. So this is a big claim if it is true. So we want to be really, really thorough and make more observations and get the evidence to the level that there is less than a 1 in a million chance of it being a fluke. So we want to be really careful there.
And do you have any idea how long it would take you to get to that level of certainty?
In a couple of years, maybe 1 or 2 years, we should be able to do that.
But let's not forget the excitement. Where does this rank for you? You've seen some extraordinary scientific moments in your career, in your lifetime. Where does it rank if it turns out that this is life?
Certainly in exoplanetary science and in my career, this is about as great as it gets. But I think even like in the broader history of astronomy, this is one of the pinnacle moments. If this turns out to be true, this would be one of the defining moments of modern astronomy.
Along with, Big Bang Theory and that sort of thing.
Yeah, but we also have to be careful whether we can actually associate these molecules with life. We think we can, but we also want to remain open to all the possibilities that are out there in the universe that may be causing this. But so far, this is the best explanation.
Let's bring in Chris Lintott, who's been listening carefully to you. Are you sharing the excitement, Chris?
Oh, I wish I did. This stuff's so difficult. I've got great admiration for Nikku and my colleagues who spend their time trying to winkle out what's happening on these distant planets. You've got to realize we haven't even seen this planet. There's no such thing as a picture of it. We only detect it when it happens to get in front of the star. And what we've learned is that there's a remarkable diversity of planets in the Milky Way. It's been a great surprise of the last 20 years. It's pretty much every planet you can imagine exists. Places where there are lava oceans, places where it rains glass, places that have weird orbits around their star. And so I think what we're learning is that extrapolating from Earth is really difficult. So on Earth, it's plankton that creates this dimethyl sulfide, but there are many other possibilities out there in the cosmos. And so I'm reveling in the arguments that people are having about this. Some people think it's an ocean world, as Nikku does. Some people think there might be a magma ocean there. Some people think this chemical is detected. Some don't. Some think that if it is detected, it would be life. Others are busy in their laboratories working with chemists to detect it. So it's a mess, is where it looks from where I am this morning.
We should explain you're no mere presenter of a telly programme. You're a professor of astrophysics at the University of Oxford. So you're part of the argument. So you wish Nikku well, but you're a sceptic, Chris.
I think we've got to be very careful about claiming that this is a moment on the search to life. That we've got such moments before. There have been places and claims in our solar system. For example, there's a rover on Mars that keeps detecting methane coming from underneath the ground. That's a biosignature on Earth. It's produced by cows, amongst other things. But we can't even say whether that methane on Mars is biological, and we can go to Mars, we can land robots on it. Trying to do this is really difficult. It's really important work, and the paper's great that's come out, but I don't think we'll see this as a transformational moment. It's part of a huge effort to try and understand what's out there in the cosmos.
I'm going to give the Cambridge man a last word over the Oxford man. Not, of course, that this would have anything to do with rivalry between these two great institutions at all. Yeah, Professor, what do you say to him?
I mean, this is the difference between a practitioner and a commentator, right? I mean, from a practitioner's point of view, this is the as best as it gets in science, and you just have to recognize it. But for that, you have to be in the field, not outside. But I think, this is the greatest moment, I think, in our search for life elsewhere, and we'll see where this takes us.
I think the argument might go on for a little while longer, as they say. Professors, both, thank you very much indeed for joining us.
Okay, so the astrobiology and astrophysics community rolled up their sleeves and decided to test his claim to the max. And Jake Taylor, astrophysicist studying the atmospheres of exoplanets, published a paper on the 22nd of April demonstrating that a flat line, just no features whatsoever in the atmosphere of K2-18b, actually fits the data that Madhusudhan and his team presented. Another paper published by Wellbanks et al. Pointed out that hydrocarbons can explain K2-18b spectrum without the need to invoke DMS and DMDS. So the independent consensus of studies from other astrophysicists and astronomers and astrobiologists, they just concur that there's no detection of DMS and DMDS in K2-18b's atmosphere. Definitely, I will say that this paper that I might be giving a really harsh review of is just great at the first steps of really determining how robust we need to be in terms of detecting a biosignature. But the problem isn't just like the methods of the paper. If there was just more caution to the analysis of the paper and it had been published, I think it would have been okay. But not only was there gaps in the methods and the presentation of the findings in the paper, but there was a huge exaggeration to what was said to the public in press releases and what was said directly from the scientists. So I think the whole debate of K2-18b is really fun. It's really cool to take that deep dive into. It's just very clear that we need to be very careful with what is not only presented in papers, which should already be given, but then what is actually said to the public. But yes, unfortunately, I come with bad news and I say that I don't think we found life on K2-18b. If you read the paper, if you have any of your own opinions, I'd love to hear them. I'd love to hear what you think, and thanks so much for watching.